Hello, welcome back. I'm actually recording this time. You'll see that I've already clicked the next puzzle. I started reading this and then realized. Spoiler blocking headphones. This is what we're doing. Like many people in the office, I am a huge fan of the Something miniseries, Get the Throne. The heroics, villainy, and sudden plot reversals have my wife, Xiao Mei, and I waiting with bated breath for each new episode. Unfortunately, we missed last night's, and this morning I overheard people in the office discussing the latest twist before I could say anything. Surely there is some way to prevent being spoiled like this, perhaps with headphones that replace discussions of certain television shows with scrambled audio? Man, I need some of these sometimes. Sorry about that, mate. You want to make a list of words to listen for and we can have those trigger the audio override? I have put a suggested list for several internationally popular Chinese shows on your desk. Hopefully you can find it. I can, it's right here. Truth Investigators, Get the Throne, Memories of Tomorrow, My Roommate is a Lamia. Alright, so those are the things I'm going to need for this. NLP. Some circuitry. Spoiler blocking headphones. Audio in is a simple input connected to an omnidirectional microphone. Which one is that? Simple input, so it must be this one, because that's XBus. Audio out is a simple output connected to a pair of headphones. Keywords is a non-blocking XBus input connected to a natural language processing device, NLP, that detects spoken words in an audio stream. Override is a simple input connected to a button. The signal from audio in should be copied to audio out until a keyword from the spoiler-related keywords list for acclaimed television series Get the Throne is detected, after which audio out should be locked to a value of 50 until the override button is pushed. Right, and as we've seen in this world, audio data uses 50 as the neutral value because it uses simple I/O, and that's where the 0 is. Look in the supplemental data section of the manual to find David and Xiaomei's spoiler-related keywords for various television shows, but only for Get the Throne. So we don't care about Truth Investigators, Memories of Tomorrow, or My Roommate is a Lamia. Man, if Lamia is a spoiler keyword for that, you won't hear much, huh? Let's look at these for a moment. Lamia, succubus, bass guitar, seatbelt, tissue paper, dental insurance. Speculate about what that show's about. Podcast, boyfriend, trolley bus, shrub, aquarium, collector's edition. For Memories of Tomorrow. Emperor, Centurions, Poison Master, Midwife, Dwarf Rebellion, and Shadow Zone are the ones we're looking for here. Why pair of numbers? Okay, so if not negative 999... I always get pairs of numbers, I think is what I'm seeing. Also, every keyword apparently can be indexed in a 3-digit decimal number. Truth Investigators, murder, basement, tennis racket, birthday, mother-in-law, mushroom burger. Alright then. But we don't care about Truth Investigators. So now, hold on, this is, okay, so here's a spoiler, 575645, whoa, that's Poison Master. Alright, so Poison Master is uttered right here, 356, 309, would that happen to match any of these? No. Nope, that's just other words, also indexable in that amount of space. Alright, so override resets it to... after which audio out should be locked to a value of 50 until the override button is pushed. Okay. This looks complicated. Maybe not so much how much data is it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so definitely fits in one of these. So it's two values I have to compare. Am I going to read through this entire bank every time looking for the first half of the keyword? I guess so. So if I get a match on the first half, like I'll read through first 6. If I get a match anywhere in first 6, I'll switch to the second, which will involve some address I/O and some slower stuff. But overall, that'll be faster than going through 12 each time. Well, I mean, that wouldn't even work, I guess. Or I could have 2 of these. Okay, so tasks are audio transfer, pattern matching, and the override latch, and then resetting that, or the blocking latch, and then resetting it with this button. All right. 3 simples. Okay. So data from here goes there. Oops. Well, I should input some data here. I think I know how I want to do this. 711-495-575. Whoa. 712-356-138. Ah. Five 73160-645. Nine 17361-420. I forgot. 361-420. Okay. And if I don't want to count to 6, I can go till I hit a 0, then add 7 to the address to check for the second component if I'm going to do that, then set it back to 0 when I'm testing the thing. Okay, so, alright, I'm starting to see how this will make sense. Address line, data line. This thing, and then that's going to have to be I/O for... Okay, you'll have to be a bit wider. I don't think you're going to use simple... Oh, you might. Oh, okay. Alright, so... NLP is non-blocking, right? Or keywords is what it's called. Non-blocking. All right. I guess I'll do that. No, I don't need to be there. Okay. So if something is in here that's not -999, I need to compare it against this first column. It doesn't matter what's accumulator and what's dat. I'm not going to be arithmeticking on either of them. Wait, I can do better. Take x2 ac. No, I do need to, okay, x2 dat. Take dat 0. Oh boy. So break out of the loop. I'll do that. I don't know if this is the way I want to do my control flow, but anyway, after I've done all that, I can finally test for equivalence. inequality between these. This is so not going to fit in these lines the way I'm doing it now. So if I've read a 0, I'm done. But if I've not read a 0, then I'm going to compare it against that value that was coming in. Plus... oh dear. Okay, no, I do want to put this in dat. Because I will actually be doing some operations here. Okay, so the data coming in goes in dat. That makes sense. If it's nothing, then I just wait. If it's something... I read a value from here. If it's 0, I break. If it's not, I compare it to what I had read from there. So if I get to the 0, I actually need to... No, I don't. No, it's fine. Never mind. Okay, so if I'm not on a 0, and that does equal... move x3 ac, because I don't care about that anymore. I got the match. I know what it is. Add 7, move ac, x3, so I jump over a column. Tech x2 dat. I'm not using this 0, but it's there. Okay, so I'm very much out of instructions here. So I think what I want here is a dude whose sole purpose is comparing against these keywords. So you'll sleep... okay, yeah, so I'm not happy with any of that. I'm going to just delete it and redo. Let's assume something will come in x0. I can keep some of those instructions. I can't redo. That's fine. Don't worry about it. Well, yeah, so why did I delete and then put back? Whatever. Well, wait, how is this going to be different? Just in that I can skip those instructions. Well, how much does that really help? A little bit. Move x0 dat. And then the rest of this is the same. It feels to me like I should be able to do better than... what do these cost? 2 yuan? Maybe I'll just put a second one. No, that would pin limit me though. So if I'm done, I jump to... let's just call this end. Because yeah, I'm not breaking out of the loop. That's its natural end. Sure. So read the address, add 7, write the address. Check if whatever's over here matching that is still a match. And if it is, then I'll move a positive result back out the pin that woke me up. Otherwise, I'll move a negative one. Oh, interesting. Check this out. I can actually just So if this test fails, no, then I want to continue the loop. If that test fails, I continue the loop. Otherwise... Well, if this test fails, I also want to continue the loop. So if... Oh, but if this test fails, then my address pointer's over there, and that'll mess everything up. Ew. I don't like that. Okay, so how do I get the corresponding value without having to do, like, all this, and then do it in reverse if I don't get a match? I don't have to worry about that, because there are no pairs that share the same first thingy. So once I get any match here, I'm done searching. I don't need to keep looking for like 711 573 or like 711 617. That's 712. That's a different number. But if there were pairs where the first was non-unique, this would be true. Okay, so that's fine. Once I get a match anywhere in this loop, so if I hit that and if I get a match, actually... Okay, yeah, so minus jump loop. So if this doesn't match... Wait, but this has already happened. Nope, this still doesn't make sense. Okay, so the control flow just is not right here. So I wait for a request. Request comes in. Oh, this is pretty messy. There are lots of problems here because the request consists of two numbers. I'm only reading the first one. TechX2 dat. Yeah, I'm just comparing against the second value. That's not right. This would be TechX X0, X2, but that'd be the only time I'd read it, and if I don't ever get a match in the first column, I wouldn't read the second number, and I don't have enough instructions to account for that. Okay, so this architecture was a dead end. So I can't have one controller with this ROM layout, with this many instructions that's going to do this job. So my function call here needs to do less work somehow. Well, I could just have this test for... Okay, I could just have this. Check for the first match and return whether it was there. Then somebody else, on a true return, would manipulate the address themselves and check for the second one. Because that doesn't involve looping through these. That just offsets the address and then resets it to 0. That's not too unreasonable. Could I then fit this into an MC4000X, maybe? X0 dat. X2AC, tech X0, Japan, tech datac. Okay, so if I'm terminating when I get a match in the first column, we're not doing any of this, we're not doing any of this. Yeah, I'm just doing that. So if it's 0, I... Move 0, X0. Jump to wait. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that all I need? Okay, so wait, I select X0. X0 dat. Move X2 ACK. Take X0. Oh, but this uses the DAT register. So that's why it needs to be this thing. How annoying. But... no, it does need a test for 0. Oh, but there's something else I could do here. If I still have the address line, I could test for address 7. Okay, sure. Okay, let's see if that's possible. So we exit ACK loop tech ACK x2. If true, return true and jump to wait. Actually, I might be able to get away without this, maybe. Let's find out. So if false, no, I do need to jump. Okay, so if false, tech x3, 7, right? Or that'll be 6 actually. 0, 1, 2, 3, 4, 5. Actually, it'll be 5. Because I want to stop when I get here. I don't need to compare against the 0. Take x3, 5. Because this happens post reading from this pin. So if you are 5, then I got through all of these without a match. Move 0, x0. Otherwise jump loop. Is that right? So that's like 0, 0, all right. Read this, test it against that, advancing the address pointer from 0 to 1. If match, or from 1 to 2, or from 2 to 3, etc. If match, return 100, and go here. Otherwise, see if I'm at the end. That's the end index. 0, 1, 2, 3, 4, 5. If it's at the end, I return false. Otherwise, I keep looping until I get to the end. Sure. Okay. And that fits, and it doesn't use the DAT register, so I can replace you with this. I'll have to change my pin numbers, of course, but that's fine. I can tuck you away up here, probably. This can go wherever. This can't move and this can't move, right? So those are the immovable components. Okay, great. So, got a thing that'll do my job there. So, next. The address line will also need to be accessed by someone else. I think it'd actually be more natural to put this. Probably I can put it all the way there. Okay, so you will be communicating with this. Something like that. This is your address line. This might end up working, it might not. We'll see. Okay, so override, sure, it's going to be P0. There's another simple, okay, so this is annoyingly crossed. Okay, but also I have this audio output, so I'm still going to need another microcontroller. So this does need the address line. It can... no, it can't manage it because this needs to leave it in whatever state it was after returning true, and this needs to do the stuff with it. Well, now I can do this, though. If I return false, I reset it. If I'm returning true, though, this will need to mess with it, and it can reset it itself. Okay, sure. So that takes one line away from your responsibilities. What about my pins, though? I got override, and I still have audio data to do. A DX300 can convert this simple input to an X bus. Do I have a free X bus for that? I totally do. Yes, I do. Check it out. Alright, so let's assume I'll be doing this. Pin type mismatch. Okay, that fixes that. Sure. So this pin here is for that. This pin here is for that, and this one's going to be for audio out. Yeah, like I'm going to fit all this in here. I might. You don't know, like, I won't. I might. Let's see. I'm going to try. Because, like, the actual audio copying is one instruction. It just needs to be conditional. I'll put 50 if I'm in override mode. Okay, so every tick. X0 dat. Tech X0 -99. If not, or if yes, jump copy. So ACK is my override. I need to sleep at some point here. Okay, so that's the override. Yeah, it's P0. Alright, sure. Yeah, there's no way I'll fit all this logic in here. Not a chance. This is wrong also. Move dat X2. Tech X2 100. I also have to manage the overrides. So if a spoiler was detected, well, half a spoiler was detected. Yeah, I still have to do the address logic here and everything. Oh. Okay, so this is a dead end because this is not enough lines. It keeps happening. Okay, so here's my next thought. I can ditch this because I'll have another microcontroller. Next thought is that there's another controller here who talks to this one and this one and what? Does the other half of the comparison? Sure, that's fine. I think. Hold on, I put down another X. 4000X, which is necessary, so I'll still have to do the DX300 thing. Okay, well, let's see if this becomes possible. Oh boy. I'm running out of horizontal space. Well, I can change that. This doesn't have to be exactly there. Okay, I'd like you to stop yelling at me for a moment. So this would be SLX X0. Move X0 X1. Tech X1 100, so if you get a match, then I'm going to do my half of the thing. Move X3 That's just taking up space. You can be x2. Move x2, AC, add 7. Move AC, x2. Still not enough space. Oof. I mean, I could upgrade you, I guess. Well, let's see if that concept works then. Okay, look at all these little bits of wire. Oh, how do I read the data? Oh yeah, you also need the data. You also need the data. Okay. So the second number coming in. Oh, right, so 2 numbers are going to come in. If you don't get a match on the first one, you'll still need to discard the second one. And report your result. Okay, so tech x3, x0. So I read whatever's on the right side, I compare to the second number coming in. I know I'm going kind of bottom up here. That's fine. Makes sense to me. Audio out can still route through here just fine, by the way. X3, X0. So if I do get a match, regardless, I want to move 0 to x2. So I reset the address. And I want to do that after I do the compare. All right, so if I do get a match, move 100 x0. Otherwise, oh hey, check it. No, that doesn't save me a line. I still have to... Okay, do I think this is complete? So I send you 2 numbers. You forward the first number to this, and check if it returns a true value. If it returns a true value, it leaves the address pointer in this state. I add 7 to it. I compare the second number coming in with whatever's in this column. I reset the address to pointer to 0. I return true if both matched. Otherwise, I return false. When I return false, I discard the second number. And I don't have to mess with the address pointer because that's already managed it. Okay, I think this seems plausible in concept. Okay, so now the concept of this. TechDat -999. So let's do this. Minus... Oh yeah, plus jump copy, sure, that's fine. Move dat x2. What's this simple pin? This is for the audio data. What? Oh, right. Am I actually writing a different program here? Maybe. Move that x2. Move x0, x2. So I put the 2 numbers in here. Tech x2 100, so when spoiler is detected, move 1 to AC. Actually, I think this maybe works. Yeah. Okay, now let's test for the override first. So it's unspecified behavior, whether if a spoiler is being uttered while override is held, if that spoiler should be silenced. In this implementation, it will be, because I'm testing override first, and then checking for spoilers. Okay, so this is the safer of the two choices, arguably. So if I tech, I just need 2 lines for this, and I have 2 lines. Cool. Plus an extra. Okay, so that's tech x1, p1. I just happen to lay that out that way. Let's put it this way so I can use the value of 100. So tech x1 100 plus move 0 ac. So that clears the spoiler blocking flag, which I keep in ac. I would rather keep that in dat. It just makes more sense to me for dat to be keeping state like that. So then change all these dats to acs, and all the acs to dats. Okay, logic check. If override is happening, then clear spoiler blocking bit. Read whatever's come in on the NLP channel. If it's not detecting a word, then just go straight to audio output. Audio output sees if I'm currently blocking spoilers. If I am, I move the neutral value. If I'm not, I copy the audio data from P0 to P1. Great. And then I sleep. Okay. And I'll fall through to copy audio data after I do this if I have... Oh, wow. So these 2 function calls here allowed me to minimize the whole check of this to 4 lines. Okay, that's not too bad. So that did actually do its job. So I move the value I already read, which is not -999, out to this pin. Then this goes through it's a whole chain, during which it also reads the second value from here to there. That stops here, it doesn't pass on to that. And then I ask for a result. If I've done all my return values correctly, that'll be fine. If I do get a result of 100, then I set the spoiler flag. Okay, I think I have a program here. It advances, it advances. I'm still outputting audio data even though a spoiler was supposed to have been detected. Okay, so it does not detect. All right. So here comes spoiler. It's entirely possible I have a data entry problem here. Not this particular one though, because 575 is there. 645 is there. Okay, so I have a different problem. X0 to AC 575. It's not that, so it goes out to X2. Okay, so move X0, X1. So this value shuffles in there. And I'm waiting for a return on X1. Okay, so this function calls this function. X0 goes to AC 575. All right, so you're waiting for a result from this. In, tech AC X2, tech X3, 5. It's not, so keep looping. You're here, doesn't equal. Not at the end, does equal. Found a match. Here's your 100. I've left the address pointer as it is, so you can manipulate it as you desire. Okay, so 100 came in. This was true. X2 is this one. So I read the second value. What's this 12? Oh, that's an address value. Right, okay. Mm-hmm. Move X2 to AC. X2 to AC. So this should get 3. It did. Had 7. 10. Move back X2. So this should jump there. Oh, I already read it, so therefore it advanced, so what I need is add 6, and then it'll work. There. Okay, that was not my only bug. Something else went wrong there. Okay, well I blocked one spoiler. So 712, 917 is supposed to be... Oh, did I mistype? Yeah, see, now that's just a data entry problem. 712, 917. Wasn't there another... no, that was just a continuation of that particular keyword, wasn't it? Okay, but something else happened here. 138, 420, 138, 420. Now that seems like it should have... worked. Why didn't it? I could have breakpointed. Whatever. Okay, so what's wrong with that? Oh, I think I might know. Yeah, my problem is that I'm stopping too early. This should be 6. Right, because this is after I've already read the value, therefore the pointer will already have moved, so I expect it to be here. That's my actual end. I knew that number never looked right. I kept talking myself into a way that made me think it was right, but it never felt right to me. And that's because it wasn't. Okay, it works. I did it. Alright, cool. How do I feel about this solution? Well, the graphs will partially determine the answer to that. Graphs tell me it's okay. Middling. Yeah, it's a lot of code. I have these 2 function calls here. I did manage to minimize the innermost function call to a 4000x, so I saved some cost and sort of lines of code. Power usage is fine. Production cost is a little high, not surprising. I got silly stuff like this DX300 converting just for... just to use an X pin as a simple one. I think I'm satisfied with that. That probably says 谢谢你. Thank you. Probably. I'm just guessing because it's contextually appropriate and I see the same 2 characters at the start, I think, and then a third one that can be like 谢谢 is thanks, 谢谢你 is thank you, as I understand it, basically. So I think that's what he said. You have made many fans of popular shows like Get the Throne happy to know they are not in danger of spoilers as they walk into the office each morning. Certainly my wife, Xiao Mei, and I are very much looking forward to last night's episode, knowing that we will be genuinely shocked by the events to come. You're going to love it, man. I couldn't believe the Emperor was actually alive this whole time. Well, we should have applied it to text. The whole time I was reading this, when I could see Joe's icon out of my peripheral vision, I saw this joke coming a mile away. But just because it's obvious doesn't mean you shouldn't do it. I wonder how many puzzles are in this game. I wonder if I'm actually getting toward an ending of some sort. Maybe not like the very end of puzzles, but like ending of the first major story beat. Maybe. Because yeah, this feels like something climactic. And I notice my list of things I can scroll down to is not growing as it used to be. Okay, cool. So 3 more actual puzzles before I find out the answer to that. I'll put on my spoiler blocking headphones until then so that I won't know the answer until I actually get there. Anyway, cool. So I'm happy with that. See you next time to hear about Cool Dad.